users saw error, unsupported data type, and queries failed after migration. The developer assumed all BigQuery data types had direct Snowflake equivalents. Migrating to Snowflake means moving your data, schemas, and workloads from another data warehouse to Snowflake's cloud-native platform. Think of it like moving from an old apartment to a new, modern one. You need to pack your furniture, label boxes, and maybe change some items. Snowflake is like a smart building where you can add or remove rooms as needed. Snowflake migration involves moving your data, schemas, and workloads from a source warehouse, typically through ETL or ELT pipelines, into Snowflake. Its unique architecture, separating storage and compute, automatic scaling, and near-zero maintenance, makes it attractive. But differences in SQL syntax, data types, and performance optimization require careful planning. Before migrating, thoroughly assess your source warehouse. Identify databases, schemas, tables, views, stored procedures, and functions. Document data types, indexes, partitioning, and proprietary features. That assessment drives the migration plan onto your Snowflake target. Collect all DDL statements for conversion. For Redshift, use pg-get-viewdef. For BigQuery, query information schema tables. For legacy, use show-create-table or equivalent. Snowflake uses a different SQL dialect and data type system. We parse the source DDL, map types to Snowflake equivalents, replacing distkey, sortkey with cluster by, BigQuery array to variant, legacy money to number, then generate the Snowflake DDL. Clustering keys replace partitioning, and legacy indexes aren't needed. Here's an example of converting a Redshift create table to Snowflake. Note the type changes. BIGINT to number, 38, 0, timestamp to timestamp NTZ. The distkey and sortkey are replaced with cluster by. Start from your source system, then choose a data transfer method based on volume and latency. Use copy into from cloud storage with external stages into Snowflake tables. For continuous ingestion, use SnowPep. For additional flexibility, leverage third-party ETL tools. For large datasets, use compression and validation mode on Snowflake tables to catch errors. Create an external stage pointing to your cloud storage. Then use copy into to load data. The validation mode option returns errors without loading, allowing you to fix issues first. Start with the original query, then rewrite it to leverage Snowflake's features. Replace BigQuery's UNNESD with lateral flatten. Use clustering keys on frequently filtered columns and materialized views for aggregations. Avoid anti-patterns like select. Finally, run the optimized query in Snowflake for execution. Snowflake doesn't require distribution keys, so joins are simpler. For arrays, use lateral flatten instead of UNNESD. Migrate stored procedures and UDFs to Snowflake's JAVASCRIPT or SQL-based procedures. The conversion step handles Redshift's PL/PG SQL to JavaScript. For simple logic, use SQL UDFs directly, and BigQuery's UDFs in SQL or JavaScript can be ported as is. Finally, test each procedure to ensure correct behavior. Here's a Redshift procedure converted to Snowflake's JavaScript syntax. Note the use of Snowflake execute to run SQL. After migration, validate integrity by comparing the source table against the target, row counts, checksums, and sample records. Use minus to find differences, run a subset of production queries, and monitor query history. Use minus to find rows that are in one table but not the other. This helps catch any data loss or extra rows. After migration, optimize for cost and performance. Set up resource monitors, enable auto-suspend, use automatic clustering and materialized views, and don't forget to implement time travel retention. Create a resource monitor with a credit quota, then set triggers to notify at 80% and suspend at 100%. Assign it to your warehouse to enforce the limit automatically. The root cause: the developer assumed all BigQuery data types had direct Snowflake equivalents, but geography and array STRUCT were not directly supported. The copy into command failed, and queries returned errors. The fix starts with a BigQuery export, Then we convert geography columns using stgeography and array struct to variant using parse.json, then copy into the Snowflake table. Always map source data types to target types before migration, test with a subset first, and success follows. Here's a common mistake: assuming all data types have direct Snowflake equivalents. BigQuery's geography and array struct need conversion. Without it, copy into fails. The fix: convert array struct to variant, which is a supported Snowflake type, resolving the array issue. Without validation mode, a full migration risks discovering errors only after the load. Adding validation mode equals return errors catches them during the copy instead, saving costly rework. Forgetting a resource monitor on your warehouse lets idle compute burn credits unchecked. But adding resource monitor equals my monitor enforces a credit limit to keep costs under control. To debug migration issues, use validation mode to get error details. Then check query history using result scan and last queried to capture slow queries. Compare row counts with minus, resize warehouse, or add clustering keys. Let's review common interview questions on this topic. Know the key differences between Snowflake and Redshift, how to handle nested fields, and validation techniques. Common questions, straight answers, use copy into for data transfer. Map types carefully. ETL tools like Fivetran work well. To summarize, assess your source warehouse, map data types carefully, use copy into with validation, validate data integrity, and optimize for cost and performance with resource monitors. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.